I'll try to show you that this new technology, again, I repeat myself, it's not yet a product. It's a concept, and it will become shortly a product. And we also collect feedback about the community in order to really fit and tailor suited to customer needs. For those that are already familiar with MDTools, what we are seeing now is not integrated in any CAD application. It does not require Inventor, SolidWorks, or any CAD application. The CAD system becomes Chrome or Firefox or Edge or a browser, really a browser. It comes with a huge library of cavities. This is like an MDTools library, so you find most cavities and footprints of the hydraulic industry, and it can talk to MDTools, and it can talk to other technologies that we provide for the hydraulic industry. So basically, for those that maybe are familiar with Sun Hydraulics product and are familiar with Quick Design, the output of Quick Design can really be imported in this technology, but not only from Quick Design. We have other customer adopting our auto router technology that is compatible with what we are showing here. This platform is also compatible with MDTools, natively compatible, and we'll see a small example. And this platform is also able to start design from a circuit diagram made now with HyDraw, and I will show you shortly how to import a diagram and design a small block in Manifold Designer. And in the future, it will be integrated also in our NetSchema, which is our cloud application. So we have a vision around how the cloud software is going to help the hydraulic industry, and we are trying to build a lot of solution around that. So let me start playing with this software. It is very easy. So we try to address the different challenge needs for designer. So an experienced designer will very good with a CAD, could be SolidWorks or Inventor. An application engineer, a sales-oriented person, may not be that high skilled with CAD application. So we try to make a software that is easy to use and not so complicated in terms of commands. So we can quickly change a block size. So let me try to build a small subplate. So I want to make 80 millimeter length, and width is maybe 60, and height is 40 millimeter. And let's say that the mounting face is the top. And I can go into my folders and let me look for a small NG6 footprint, ISO 4401. For those from US, this is a DO3 footprint, and I can insert the footprint. So as you can see, really, this is drag and drop. We can change the face just by moving a footprint around. Changing position is very easy. You see X and Y ordinate, but you can also place, type in the position, so 40, and maybe I want to center the A and B 30 in the middle. We can apply net. For those familiar with MDTools, those are really like features like MDTools, drills. Although I'm not really interacting with the real 3D model, this is only it's viewing something, but it's not yet really a 3D model. And I can define net. So in this case, I can quickly give colors to what I'm doing. And let me do that for the B port also. And I can go into maybe some BSP ports, take a BSP 3x8, and call this port P, and insert and place the cavity. Again, it's very easy to align cavities. You see dash lines showing up, and we can quickly change the position, and we can also connect. We can do a connect cavity and really connect a cavity with another one. It's easy to stretch drills and also to incline drills. So for instance, in this case, we may want to incline this drill by, let's say, 10 degrees. And on alpha, let's make it 270. And as you see, I got a warning about exceeding drill diameter. And you can really change the diameter very quickly, 6 millimeter diameter, and also the depth, 22. And here we have made an inclined drills. It is also possible to change spot face depth and diameter. Let's make it 3 millimeter and 26 millimeter depth. In this case, maximum drill diameter. So we have a live warning when we do some, when we have some problems with the design check. We have commands to do the design check. And in this case, there are no errors, although there are no connected ports, but the design check may find dead area to working area intersections, minimum wall thickness problem, and so on. The library is very extensive, so we can find cartridge valves. Let me take HyDraw FC8-2 and insert. And again, we can connect a cavity to another port. If the block is too small, we can touch the block and change the width, length. Let's make it 100 millimeter. And again, we can move cavities all around very quickly. Stretch drill. And we make a new connection. So in this case, what I'm doing is basically, and of course, I ask a bit of imagination. This is just a scenario where you may have a drawing from your customer. He says, can you do a block similar to that? And really with this tool, I could exactly start with the same size and apply cavities and do connection and verify if really I can do. And I can do it without the need of a CAD platform. Although when I want, I can save it into an MBXML file, and then I would be able to manipulate this MBXML file into MDTools or other software that can read it. So this MBXML file is a proprietary file defined by VEST that has all the geometry and also the machining information for a manifold block. And as I said previously, this file format is used by also our auto routing technology. I'm not going to save now. This is not really something that has much value. But I want to show you a second case where we can use this technology. So the first, as I already said, is you have a drawing from your customer and you want to make exactly the same block. And this can be done without a CAD application. A second case is really when you want to design a block from a circuit diagram. Something like you do with MDTools, and there you require a desktop software, but you may have an application engineer that is smart enough to start designing, maybe not completing too much, but you want to give him the ability to start the design in order to save time in your design department. So I start with a new block. So in this case, I will just refresh. And now it's again on a new block. And now instead of searching for cavities, I will go to my schematic and I'm loading a file. For those that are already HyDraw customers, and I have a small diagram here, the same interface will be available also in NetScheme at a certain point in the life cycle of NetScheme. So when we draw diagrams with HyDraw, we have the ability to export to MDTools. So with export to MDTools, we just take a manifold diagram and generate an XML file, and we can export this XML file into our design folder. The same technique is adopted for those using, for instance, HyDraw EID or Smart Connect and Quick Design, or the Danfoss Easy Manifold 3D. This is the same XML file containing the information for the schematic. So the XML file has the component information, as you see, item 2, item 3, and item 4, and also the net. So in the diagram, when we click on net, we can see it highlighted in the schematic. Now, if I import this XML file into Manifold Designer, I can browse and select my drawing one and click OK. Now, the same list of components that I had in my in HyDraw now is available here. And really what I can do is just drag and drop of the items in the block. This is a very large block, so let me just make it smaller, let's say 80 by 80. And let's try to fit into 60 millimeter. Again, we can drag cavities. Let me take this cavity here. We have colors, so we can see which cavities has to be connected with different items. So let me move this. That should be a pressure reducing valve. I put it here. Let me add some material on the width and also on the length, and I remove it here. So I can connect my blue line directly here. As always, you can specify precise position. When starting a design, people really normally take a lot of time in placing sketches and position. Here, really, it's very, very handy. We can just type in 40, 30, and the cavity will jump to the position. Here, again, we can say this is 40, so it's aligned, and also this one might be at precise position, 40 millimeter. In MDTools, we have several commands to automatically optimize depth. Here, this is not yet. We don't know yet if it will have again all the same commands as MDTools, but we can manually using the stretch cavity and do all modification to drill depth very, very quickly without too much interaction in a 3D model. And we can program this software to really behave like we want, because we don't rely in this case on any specific CAD engine. We can just drag and drop a new cavity here. And so in this case, I want to move this cavity and make it maybe 30 millimeter. And the same here, and we make it 30 as well. And I want to position this cavity here. Now I will need to make some connection, so I can take construction plugs. So I will go to my library, and I can go to my, let's take expander. I take a large expander, 10 size. We can also double click on an expander and place it here. And as you see, for plugs, we automatically display the 3D model of the plug. So for instance, if we take a screw plug like a BSP port as a plug, a 1x8 BSP as a construction plug, this will show also the plug. We have the ability to turn on and off the plug visibility to help clarity when designing the block. Deleting a cavity is just delete from the keyboard. Now I do connect. And again, while doing connect, I can also position precisely. So let's make it 30 millimeter and click OK. And now also this one, I want to make it exactly the same position, 30 and 60. And I can stretch the drill. And I can move this cavity maybe slightly, 28 millimeter. Now we can go again on the schematic, and we see that we miss all the external ports. The schematic will be available in cavities fashion or nets fashion, where we can see all the cavities belonging to each net. So I'll take a tank port, the tank line, and insert and position it somewhere here. This is not a construction port, and maybe the tank port I can position here and do a connect directly with port number 2. There is not enough room here, so I can just move my cavity. And you can use directly this dialog in order to move the cavity. And again, maybe in this case, I will slightly offset my cavity, and I will slightly offset the plug, and I can stretch the drill. We don't need to be very precise. One challenge of designing manifold is really that we need to reach to a solution as quickly as possible. Then we can spend time in making good precise positioning without decimal places and so on. But we should not waste time at the beginning, because at the beginning is really we need flexibility. We need to change face to cavities and find a good layout, a good solution to what we are doing. Let me place some other cavities here. And again, now I can maybe change face. I put the yellow on the other face. And I connect with port number 2. And again, here there is a collision, so I can just make it 40 millimeter. And this cavity may go down a bit. Maybe this port, let's keep it simple. We put this port here and we do a connect. Connect this one with this one. And we can move it up. And always we can be very precise with the position. 30 millimeter, 20 millimeter. And a port. Maybe a port we put on the opposite face. Down here. And we want to connect the A port with the pink line in a position of 45. Okay. And maybe we can reduce the drill. Let's keep it 8 millimeter. So in MDTools, we would have many more commands to check conformance to schematic. Now here we can run a design check, and the design check will check for errors, wall thickness. So for instance, it says that there is a wall thickness between item 4, and let's go to item 4. Item 4 is this cavity. So there is a distance of 1.48 millimeter with the external face. So it's very close to the manifold face, and that could be potentially an issue. In this case, with my experience, I can say there is no risk at all, but I didn't close the red net. So let me do a connection here with port number 2, and I'll put an expander plug on top. So I can connect now my plug with port number 3. And my block looks okay. Of course, I can insert bolt holes. Let me take a bolt hole metric, let's say M6. Let's say that one bolt is here and another one is there. Is it a complete design? Maybe yes, maybe no, maybe we need to do modification. Can we help our design department? For sure, yes. So if I am a sales engineer with some skill in manifold design, I can give this block, which is yes, maybe could be optimized. I can give him this block to my design department. I can save my block and go into and save my MBXML file. Let me save it here, and let's call it exercise 4. So now if you have MDTools, and I have now it open in Inventor, but I'll show you while I load it in Inventor, I'll open also SolidWorks. So I'll show you that the compatibility is really across platforms. I'm starting a new part. Sorry, it's going on a different screen. Well, let's do the Inventor first, the SolidWorks first. there is really no difference in how I import the MBXML. So let's do SolidWorks only. MDTools is an add-in for SolidWorks. And so in this case, I can really just import my manifold, the one that I have just made, which is in the manifold exercise 4. And now MDTools is taking the geometry into SolidWorks. And here I can complete with all the remaining items. I can do further checks, or here I, for instance, can do a volume optimization. So I can see with my experience of designer that I can remove 10 millimeter here. And now really this is done in SolidWorks with all the SolidWorks command thanks to MDTools. Here I can make assembly, machining drawing, do optimization, and go to our CAM software and whatever it is. But this is not an MDTools demonstration. So I want to show you a different approach. So as we have seen, the first exercise was trying to build a small block, maybe reading something that was existing. The second was designing really from a schematic, and the schematic had information digitally stored starting from HyDraw diagram, but it could be also NetScheme or other solution developed by Vest with our the WebCAD technology. And now let me show you a different approach. So like I can generate MBXML file from MDTools, I'm also able to import the same MBXML file in this environment. So why not really using this also as a light editor, light modifier for what has been already designed by MDTools or by AutoRouter as well. So let me open a block that I have made with MDTools a few days ago. So that's an MBXML file again. So this is a block I had made. Let me show you it in Inventor. It was this one. And now I have it. So this is the same block, and I have made into the Manifold Designer. Well, Manifold Designer is not yet the final product name. Simply, we are describing this technology as a Manifold Designer in the cloud, but again, it's not yet a finished product. So like I did earlier, really it's amazing how easy it is to do modification, light or precise modification to a block. So here the challenge is really more when we think about editing, giving a tool to edit a block is more about which functionality should I give to a user that has not enough skill, more than concentrate on how difficult it is to do the change. Because really here the user really can just drag and drop and change and modify the geometry according to his need. So now this is not acceptable by the customer, but I can really change the position of a port there, or I could maybe drag this one here, delete my plug, and do a connection. And everything here I did without the need for an Inventor platform. Being browser-based, I could do this next to the customer, really next to the customer with the customer PC. I visit the customer, we want to study a solution together, and why not connect into this cloud tool and do the job. So no need for powerful workstation, just a browser, and this will work. So here I have just made a small change, or maybe I can get rid of this plug. Again, here the limitation might be the skill of the user. if he knows how to position and where to position components in a block in order to avoid collisions or avoid manufacturing problems. In fact, we are in our strategy, we are trying also to define different levels of usage of this platform. One is at its full potential, so like really a designer, so where there is no limit to what the user can do, and another where really we want to bind to some specific functions only for a low-skilled user. And if you think at the desktop software, in a desktop software, it's very difficult to define, to cut the functionalities because basically you normally install and you get everything. And then it's up to the user to decide what to use or not. Here, really, we have commands and we can program everything. We can really package all our solution into what is desired by our customer. So like you see here, really I can do just change face, delete, and stretch. And now I can save my block and get back to my MDTools. So in this case, I will be able to maybe import my block. And I'll be able to finish the exercise in my MD. And here is the modified block, which then I can further, maybe in this case, I really realize that I can remove some block material. For instance, this remove block material inside the block is not yet available in the designer, so it would be more challenging to do that change in the cloud as of now. But really, the set of commands is something that is being defined and is being developed constantly by our team. It is possible to measure wall thickness, so we can do a display wall thickness. Let's find some issues here. So here, if there is no wall thickness here, there is a collision, and in fact, this was one of the items listed in the design check I made, but again, it was not so easy to identify it. Now that I made the distance, I can measure the wall thickness between two cavities. And well, I didn't select the right ones, but as you see in this example, really we can isolate the cavities and show the distance between the cavities. So let me select properly. And I can say that this is better probably than MDTools, the way we are displaying the issue. So this is really now a work environment, a development environment where we are building our technology. One limitation I see is that we are not able to touch an item and highlight it in the block. But we have this possibility to highlight informations or dynamically highlight items in the block. Simply, it's time, development, and resources. So, for instance, when we do display machine sequence and we touch a cavity, as you see, we automatically gray out all the cavity and we display the information for a cavity. And so on we can do for each single cavity. So dynamically we can switch on and off colors. So it will be technically possible also to highlight issues for design checks in our block very quickly, like we do with MDTools. But here I expect to have more freedom, more flexibility, because we do really basically what we want in this tool. Is it possible to import into Inventor without having MDTools? So at present, it is not possible. But but not because we don't want, simply because it's not yet a product. But we like we have technology to automatically create 3D models and assembly and 2D drawings in our cloud technology for the manifold configurator. We have also the possibility to automatically generate Inventor files and also machining drawing out of it. So it's not yet available here in what we are seeing here, but practically, yes, we will be able to generate Inventor files and machining drawing automatically out of this tool. I am not able to demonstrate, but if you ever looked at Sun Smart Connect or Easy Manifold, I really don't want now to bring up OEM's product. But there, what we do is we have a technology that makes an automatic manifold design and creates a 3D model, assembly, and machining drawing. In this case, the technology to create the block is the human brain with our tool. So I will be designing the block, and I will be able to use the same technology that automatically makes the 3D model and the assembly and the machining drawing starting from what I have made. So the answer is not yet. We don't yet make Inventor files, but we will for sure make the Inventor files because we already do in other declination of our technology. I see another question. Can we use a different cavity library, such as one that we already use for MDTools? So yes, this is in our pipeline, not yet. So now it's embedded in our platform, but of course, when we will provide this tool for companies, for single user or organization, there they will have the ability to manage their own library, and this is how it must be. So of course, we can provide a standard library that comes with MDTools, but for a software for designing, we need to have the ability to make our own cavity or customize our own cavities. Okay, I see questions about pricing. So not yet. As I said, we are trying to find out a balance between functionality, pricing, business model, and so on. So it's not yet possible. Is there a launch date? Well, this is for us already as a production environment we use for demonstration and so on. I don't want now to tell too much about our strategy, but for sure this year we will have something working, but really this maybe we'll set up another webinar about a more detailed timeline, or you can stay in touch with our in our social media or newsletter, and we may come with more information. So sorry for not being too precise, but again, it's a platform more than a software. If I can tell you the price for MDTools for HyDraw because that's a standard product here. It's really something that is growing, and of course we have a strategy in mind, but it's not now the right moment to reveal it. If you have any other questions, really feel free to send us an email to support@vestusa.com,